Hello everyone, how are you today? So today we're going to be doing like a little bit of an overview of your quiz. So just give me a chance and I will look for it right now so you can see it. So you're going to have a PDF. It's going to look something like this. The first thing you have to do, you have to print it or you can answer it in your notebook. Just remember that you have a multiple choice, so just do your process and then choose the best answer. So you can put like, for example, you can say like 1 equals, and then you do your process. You can put like the letter that the one that you're choosing. The same one that you're gonna put here is gonna be the same one that you're gonna put on your quiz in your Google form. Okay. So what are you gonna be seeing on your test? Well, in the first part, you have to write the fraction as a decimal. And again, all you have to do then is just turn those fractions into a decimal and choose your best answer. I need to see the process, okay? So I'm going to do an example from that so you will see what is it that I'm looking for. I'm going to do this in my Jamboard. So for example, let's say that you have the fraction -7/18. And I'm asking you to turn that fraction into a decimal. Well, the first thing that you have to know is that this is going to be a negative one, right? Because your 7 is negative, your answer is going to be negative. And then you have to do your division because we know that our fractions are actually divisions. Your denominator goes outside, your numerator goes inside. Now I know that 18 doesn't fit on 7, so I have to add a 0. But if I add a 0, I have to put a decimal point. Okay, so I will know how many times now does 18 fit on 70? 3 times, right? And 3 times 18 is 54. I'm going to subtract that. That's going to give me 16. Have I finished? No, I still have more. If I still have some residual there, that means I have to continue dividing. So I'm going to add another 0. Sorry, I'm going to add another 0. And how many times does the 18 fit in 160? 8 times. And that's going to be 144. And then I'm going to subtract. Oh, it's giving me 16 again. You know what that happens. That means that if I had 16 there and 16 here, this is going to continue to repeat itself. Therefore, I know that this is going to be a repeating number, that 8 is going to repeat itself. So what is my equivalent of that fraction into a decimal? Well, -7/18 is going to be the same as -0.3 when the 8 is a repeating number. So I have to put the line there. Let's do one more. How about if I have a mixed fraction? Well, if I have a mixed fraction, for example, 7/20. Well, the first thing I have to do is turn that mixed fraction into an improper fraction. And how do we do that? I don't know if you guys remembered, but we talked about this. We're gonna take that denominator. I'm gonna multiply it with my whole number, and then I'm gonna add my numerator. So let's do this. 20 times 2 is 40, plus 7 is 47. So my new numerator is going to be 47. And my denominator stays the same. I just converted from a mixed fraction to an improper fraction. And now I can check out, now I can do my division and see what is my equivalent as a decimal. I can convert into a decimal, right? Again, my denominator goes outside. My numerator is gonna go inside. And 20 fits on 47 two times, right? Two times. 2 times 20 is 40. Now I still have some numbers there, so now I can turn this into a decimal. I'm going to put a point, a decimal point, and add a 0. How many times does 20 fit on 70? 3 times. 3 times 20 is 60. And now I can subtract. This is going to be 10. I'm going to add another 0 there. And how many times 20 fit in 100? 5 times. And 5 times 20 is 100. And this is going to give me 0. And I ended when I don't have anything else to divide by. That means that I ended. I just did my ending. Therefore, 47 over 20 is going to be the same as 2.35. Okay, now let's check out part 2. In part 2, you have to turn a decimal to a fraction. How do we do that? What if you had the decimal 0.1? And I tell you that all you have to see is how many times do you have to move that decimal point, so you will know what you have to divide it for. In this case, for example, it's going to be 1 over 10 because it has one decimal point. What if I had 0.11? What would be then that fraction? Well, that fraction is going to be 11 over 100. What if I have 0.101? 111? Well, that is going to be simple. That means I have to move my decimal point 1, 2, 3 times. Therefore, I'm going to divide this by 1,000. You see the pattern? What if I have a repeating decimal? What if I have 0.1 where the 1 keeps repeating itself over and over and over? I told you we have a simple question for that, right? A simple trick. You just have to put it over 9. Instead of 10, you will put it over 9. What if you have two numbers that are repeating, like 0.12, and the number 12 is going to repeat itself over and over again? Then you're going to put the 12 over 99. You see the pattern? Easy. Now then you can also simplify. For example, on 12 over 99, we can simplify. By what number do you think we can simplify that? By 3, right? So let me look for another color because I am simplifying. So that means I can divide this by 3. And 12 divided by 3 is 4. And 99 divided by 3 is 33. And there I simplified it. Now you're going to tell me, but Miss, do I have to simplify this equation? Yes, every single time that you can simplify your equation, simplify your answers. Next part. What do we have in next part? The next part, you're going to find the sum or the difference. I mean, you're going to add or subtract your fractions. And look here for another color. So for example, if I have 1/2 and I'm adding 1/2, the denominators are the same. So I'm going to leave that denominator there. And I'm just going to add denominators. 1 plus 1 is 2. And I know that if I have the same number as the denominator and the same number as the denominator, that is a whole number, and that is going to give me 1. Let's do another. What if I have 1/4 plus 1/2? What if I have a fourth plus a half? Now they have different denominators, so I have to find a common denominator. And I know that they will have my least common denominator. In this case, between 2 and 4 is going to be 4. How do I know that? Because all the multiples of the table of 2, 2 times 1 is 2, and 2 times 2 is 4. And in the table of 4, 4 times 1 is 4. They have a common multiple, and that is the least common one, right? Therefore, I know that my least common denominator is going to be the number 4. So the first one is already with the number 4, so that's going to stay the same. And the second one, I have to think, what number can I multiply the number 2? That's going to give me the denominator 4. Well, 2 times 2 is 4. So that means I have to multiply this by 2. So 1 times 2 is 2, and 2 times 2 is 4, and my equivalent is going to be 2/4. Now they have the same denominator. Now I can solve this. And again, my denominators are going to stay the same because they have the same denominator. And my nominators are going to be added up. 1 plus 2 is 3. And that is my answer. Let's do one more. What if instead of that I have a mixed fraction? What if I have a mixed fraction? What if I have 1 and 1/4, right? Plus 1 1/2. What if I have that? They're mixed fractions. They have a different denominator. Well, the first thing I have to do is turn that mixed fraction into an improper fraction. And again, how do I do that? Well, I'm going to multiply my denominator with my whole number, and I'm going to add my numerator. Let's do this. So again, my denominator is going to be 4. And 4 times 1 is 4, plus 1 is 5. Same thing on the other side. 2 times 1 is 2, plus 1 is 3. Now I can find a common denominator. I know that between 4 and 2, that's going to be 4. So the first one is going to stay the same because it's already 4. And what number do I have to multiply 2 to give me 2? Well, I already know that that is by 2. So in my numerator, I'm going to have 3 times 2 is 6. And in my denominator, I'm going to have 2 times 2 is 4. Now they have the same denominator, and I can add them. 5 plus 6 is 11 over 4. Did I finish? No, I did not, because now I have an improper fraction. Let's make it a proper fraction. 4 and 11. That fits 2 times. 2 times 4 is 8. And 11 minus 8 is 3. So this is the same as 2. and 3/4. And the last part of your test, it says simplify the expression. And here you're going to have some variables. I'm looking here for an example. Okay, so for example, if I'm adding fractions with variables and I have, for example, 2x over 5 plus x over 5, again, I have the same denominator, so that is easy peasy, right? I'm going to stay with that number 5, and I can add my numerators. Now remember that if I don't have a number next to my variable, I will always have like an invisible 1 there. So 2 plus 1 is 3x. I'm going to just pass the x. Let's do one more. What if I have 2x over 5 plus x over 10? Now I have different denominators, so I have to find my least common denominator. And if I do all the table of 5 and I do the tables of 10, I will see that they both have the number 10 on them. 5, 10, 10. They have the 10 is common between those two. So how many times do I have to multiply that 5 to give me 10? I have to multiply it 2 times. Now the 10, I don't have to multiply by anything because if I ever multiply by something, it's going to be by 1. It's already 10, my denominator. Now 2 times 2 is 4x, and 2 times 5 is 10. And the other one just going to stay the same. And again, I may not see it, but there's a 1 there. Now I have the same denominator, so I'm going to leave it there. And how much is 4x plus 1x? That will be 5x. Did I finish? No, I did not. I can actually simplify that, right? I can divide, 10 is divisible by 5. Therefore, I can divide them both by 5. And 5 divided by 5 is 1. 5 divided by 5 is 1. And 10 divided by 5 is 2. So this is going to be 1x over 2. Or I can rewrite this as x over 2. Now, in the last part, you're going to have a bonus. Let's go check it out. This is your test. At the last part, you're going to have a bonus. You're just going to tell me which decimals are terminal decimals or which ones are repeating decimals. And at the end, you will have your due date, the Google form link, my email, and an important message. And that message says that you have to send or you have to upload your procedures. I need to see where are you getting your answers. You cannot just give me your answers and that's it. If I don't have that, I'm sorry, I cannot give you credit for that work. I need to see your procedures. That's very important. How would you do that? Well, at the end of your Google form, you're gonna have a part here. You're not gonna see it like this, right? You're gonna have a part here where you can actually upload your Google form. You can upload a PDF or an image to your link, to your form. If you have doubts on how to do that, in my YouTube channel, I have another another video that tells you how to upload it. And again, another thing that I wanted to show you is that I had a little bit of trouble with what is a decimal that is a repeating decimal. For some reason, it's looking like that. As you can see, that is number 2 on your test. If you go to the first part, number 2, you see that that is 27, 0.2, and the 7 is repeating. For some reason, that line of repeating is looking like this in my Google form. So I apologize for that. Just let yourself guide yourself by your PDF. And that will be all for today. I really hope that this video was helpful. You know that you can always text me by WhatsApp or call me. You have until Monday to send it. I will not receive a quiz after Monday. So please do this on time. You have the time, do it, okay? I wish you the best of luck and see you in our next class. Bye.